to FTP on bio-inspired computing for data analytics. The sixth session will be colony optimization by Dr. Venkatesh Panditi. Respected Dr. Venkatesh Panditi. Good afternoon, sir.
Good afternoon, ma'am. Let me switch off my video.
Sir.
Yeah, good afternoon, ma'am.
Sir. Good afternoon, sir. I request Dr. K. Anupriya Madam to introduce the resource person.
Thank you, Sherwani. Good afternoon, sir. It gives me great pleasure to introduce our resource person, Dr. Pandiri Venkatesh. Sir did his MTech in Computer Science from University of Hyderabad and received doctorate from University of Hyderabad. Currently, he is working as an assistant professor at Indian Institute of Information Technology, Design and Manufacturing, Kanchipuram, Chennai. His research interests are combinatorial optimization, heuristics, meta-heuristics, swarm intelligence, multi-objective optimization. Sir published more than 12 articles in well-reputed journals and conference proceedings. We are honored by your presence, sir. Thank you. And now I request Dr. Venkatesh to take over the session. Over to you, sir.
Okay. Thank you very much for the nice introduction, both by Lavanya and Anupriya. Excuse me. So I'll switch off my video during my session. So yeah, I shared my screen. Now, is it visible?
Yes, sir. It is visible, sir. Visible.
Okay. So you can interrupt me anywhere in between whenever you feel like asking the queries or doubts. So today's my presentation will be on artificial bee colony algorithm for a combinatorial optimization problem. So this is the outline of my presentation in today's talk. So in the beginning, we will discuss about what is basically artificial bee colony algorithm. And subsequently, we will see what is a combinatorial optimization problem, and we will try to solve one of the combinatorial optimization problem, that is GCTSP, by using the artificial bee colony algorithm. Then we can see some conclusions and references after that. First of all, we should discuss about artificial bee colony algorithm. So what is the basic motivation behind proposing this algorithm, and how it is inspired from the nature. So basically, this artificial bee colony algorithm is like one of the swarm intelligence inspired by swarm behavior in the natural phenomena. So swarm intelligence mainly have two fundamental concepts. One advantage of this swarm intelligence is that they will be self-organizing, and self-organizing means that it is having these features. One is a positive feedback, means that whatever the information or food sources that they are being associated with, or whatever the food sources they are extracting, they will try to maintain the feedback related to that, whether it is a positive feedback or negative feedback. And there will be some fluctuations also in between due to the dynamic behavior of the problem or something. And there will be some multiple interactions between these swarm. Swarm means a group of insects. Any group of insects can be called as a swarm. And this artificial bee colony algorithm is one of the swarm inspired technique. And another fundamental concept in this swarm intelligence is that the division of labor. Suppose if a human being or if a single computer is doing the work, so they can do the work in a sequential manner, right? But by usage of this swarm behavior, there can be multiple bees or ants, whatever you name it, the swarm. They can perform the task in a simultaneous manner, means that the work or the optimization can be done in a parallel manner. And that is what actually required for solving any optimization problem. We will see some examples of in the later slides. regarding how this ABC can be used, but we will see the natural phenomena of this bees. So basically, we are seeing about the natural behavior of honey bee swarm. So based on the type of job they are doing, these honey bees can be divided into three categories. One is employed bees, and there are two more. That is, one is onlooker, another one is scouts. In total, there are three types of bees. One is employed bees, second one is onlooker bees, and third one is the scouts. So these three categories are there in the bees on the type of the job that they are doing. So what basically happens in the natural phenomena is that all these bees will be there in the hive in the beginning, and every bee will be associated with a food source. You might be already knowing these bees are going to either flowers or some food source they will identify, and they will try to bring that nectar amount from those flowers, and they will bring it back to the hive, and they will deposit that nectar amount, whether it is honey or something. They will deposit in the hive. So the food sources can be either flowers or it can be anything. So they might be, these food sources might be somewhere nearer to the hive only. And how much easily these bees are able to extract the nectar. Sorry. So as I said, there are three categories of bees. These employed bees actually will be associated with the food sources, particular food source they will be associated with, and they can carry and share information about it. So they will be having the information related to the food source, means how much distance it is located from the hive, and how much amount of nectar is available in the food source. And is there any possibility of finding a even better food source in the vicinity, means in the neighborhood, is there any possibility to get better food source? So all this information these employed bees will be having, and these unemployed bees will be waiting in the hive, looking for the employed bees to come to the hive, and there they will perform this a dance operation, so where they will share the information regarding their food sources. So based on the quality of the food sources, means how much nectar is there in the food sources, some onlookers can be recruited for that particular food source. We will see the job of these bees one by one. Suppose there is a hive here, and the bees can go up to a 10-kilometer radius. So ultimately, the aim is to find out a food source where there is a lot of nectar, or a lot of, I cannot say honey directly, there might be some amount of nectar is associated with each of the food source. So let us assume that there are multiple food sources available in the vicinity. So this employed bees will be associated with these food sources, and they will be extracting the nectar from them, and they will come back to the hive. So in the hive, this unemployed bees, whether onlooker bees, they will be waiting for sharing the information. I will show some more figures, and you will understand it even better manner. Yeah. So these employed bees and onlooker bees, they can only search one of the food source. But when it comes to the scout, whenever a bee is not able to find a better nectar amount, then that employed bee will be automatically promoted to a scout. For example, an employed bee find out a food source, and until 50 iterations, means 50 times it came to the hive and food source, then the nectar is over in that food source, or whether it is a flower. So once the nectar is over, then that employed bee will be called as a scout. This scout is a random bee which randomly goes around the hive, in the neighborhood of hive, and it will keep on searching. Some food source will be associated randomly to this scout bee. So whenever a food source is associated with the scout bee, then that scout bee will be called as employed bee again. So you got the point here. As long as a food source is associated with an employed bee, it is called as employed bee only, right? But whenever enough nectar amount is not there, then that employed bee will be promoted to scout. Means that it is not able to find out any food source which is having nectar to be extracted. Then the scout bee will simply go around the hive, and it will find out one of the food source. So whenever it is associated with the food source, then onwards it is called as employed bee again. So how this phenomena actually happens, we will see. So they will exchange this information in the hive only. I think I will move to the next slide, where you will see this information. So during the vagal dance, what happens? They will share the information with the bees already be there in the hive. So they will be having only these three things only. These employed bees can't remember anything. They can remember only these three things. What is the direction of the food sources, whether it is flower or anything, means that they will simply remember the angle between the sun and the patch, and they will keep on moving until they reach the flower patch. And how much distance it is from the hive, we can get to know based on the duration of the dance. If the duration of the dance is very high, it means that it is very less distance from the hive. And if the duration of the dance is less, it means that the distance of the food source is very high, right? And the quality of the food source depends on the frequency of the dance. It means that if a bee is able to find out a food source which is having high amounts of nectar, then it keeps on dancing in this area. So based on that, the onlooker bees can select that employed bee. So whichever the onlooker bees selected an employed bee, they will follow that employed bee to that food source, and they will try to extract the amount from there. Once they return, the onlooker bees again will become onlookers only. They will not be associated with any food source, onlookers. They will be simply, every time they will be simply going with one of the employed bee, and they will extract the nectar, and they will come back to the hive. Again, they will be onlookers only. Again, they will be looking around to find out a very good food source. So these employed bees are strictly associated with this food source, but whereas onlooker bees always onlook on others, whether is there anyone got a good amount of nectar, some food source, they will be keep on looking. That's why they are called as onlookers. Whereas the employed bees are particularly associated with that food source only. Right? Yeah, here a food source is there, and employed bee, this particular bee is called as an employed bee because it is associated with this food source only. And once it extracts the nectar from there, it will come back to the dancing area. Here, onlooker bees will be looking after them, and based on the type of the dance, frequency of dance, and duration of the dance, they will be able to identify which employed bee is having a more nectar amount. So the chance of what you call the chance of getting interest by the onlooker bee is more whenever an employed bee is having a food source which is having high amounts of nectar. So this is the basically what happens in nature during the natural behavior of honeybee swarm, foraging behavior of these honeybees. So inspired by this, one scholar, Dervis Karaboga, has proposed this artificial bee call algorithm in 2005. And then onwards, many researchers started working on this artificial bee call algorithm. And it is very interesting that a natural behavior inspired artificial bee call algorithm is able to perform well on solving many of the problems, whether it is a continuous optimization problem or multimodal, multi-dimensional optimization problems. Even in combinatorial optimization problems also can be solved in a very less amount of time. Like you might be knowing many NP-hard problems. Whatever the computer science scientists facing the problems nowadays, one way or the other way, they might be categorized as the NP-hard problems. So solving these NP-hard problems are very time consuming, and even if you use some exhaustive search techniques also, you may not be able to find the solutions within a short time. So this is where these the bio-inspired techniques or swarm intelligence techniques. So one of that one is artificial bee calling algorithm. So for solving any kind of NP-hard problems, it is we will not be having any choice except using these techniques. Either swarm inspired or bio inspired techniques only we can come to. So Yeah, by inspiring from this natural phenomena, this Carl Voge has proposed this in 2005, and he basically proposed this problem for, sorry, basically proposed this algorithms for solving the multi-dimensional and multimodal optimization problems. So in his basic paper, the allocation of the number of bees has been like this. There will be three types of bees, as I told. So 50% of bees are occupied for employed bees and 50% for onlooker bees. In the initial paper, he proposed, but later onwards, so many parameter tuning techniques came in, and there we had the chance of changing these parameters also, whether it can be 50%, 50%, or 30, 70. It can be, we can do the parameter tuning, and whichever the parameters, whichever the set of parameters are performing better for solving a problem, that can be taken. So as we know, any kind of optimization problem requires both exploration and exploitation. So if you balance both these things, the exploration and exploitation, if you balance both these things, then only we can achieve a very good or optimal solution within short time. So as you understand, these employed bees and onlooker bees will simply do the job of exploitation. It means that they will try to search for the food source within the neighborhood only. But when it comes to the scout, it will do the job of exploration. Suppose if you take any search space, let us say, so if you want to find out an optimal solution in a search space, definitely you should maintain balance between this both exploration and exploitation. So this exploitation job will be done by this employed and onlooker bees, and whereas the exploration job will be done by this scout. Right? So these employed bees will be simply, they will stay on the food source and they keeps on looking in the neighborhood. So in the neighborhood, if it is able to find out any good food source, means any good flower having high amounts of nectar, then they will be moving to that food source. So it is called as a exploitation, right? Means they will try to exploit the nearby place, in the neighborhood place, wherever the food source is associated. Same way, onlookers also will do the exploitation procedure only. But once they come back to the hive, they will look for other employed bees. So we will see the mathematical formulation of this algorithm. So if you are having any doubts or queries so far, you can raise now regarding this. Okay. Otherwise, I will simply continue. So how this algorithm has been formulated, we will see. So the same thing, whatever I told earlier, if an employed bee whose food source has been exhausted, then it becomes a scout, and scouts are simply exploring the search space. So in his first paper, this Carl Voge proposed that number of employed bees should be equals to number of onlookers, but it can be tuned according to our parameters. So every food source we can say that as a possible solution to the problem. Suppose if you are solving any traveling salesman problem or some other continuous optimization problem, like if you want to maximize x plus y according to some equation, right? So every food source can be considered as a possible solution to the problem. So like the way 100 employed bees will be there, every employed bee will be associated with a possible solution. So this is the advantage of this artificial beacon algorithm. If you are doing the exhaustive search, let me tell you, once this is done, I will show you an example where it can be exactly used. So this is the main steps of algorithm. So initially, every bee is called as a scout only because none of the bees are associated with any food source. So every bee is called as a scout only. So these scouts will be sent to the initial food sources. And once the food sources are identified and associated with the scouts will become employed bees. And these employed bees will be sent to the food source for determining their nectar amounts, how much nectar is there. And based on the amount of nectar they are able to find out, they will come back to the hive. So there they will perform the dance, and in the dance, whichever the food source is having high nectar amount, that is having the possibility of what you call, that is having the possibility of getting interest from more onlooker bees during the dance. So if more onlooker bees are interested in that food source, they will be also sent to those food sources for extracting the nectar amounts and searching in the neighborhood. And once this exploitation is done, what happens continuously for some, you name the parameter, whatever it is, 10 to 50 times, if one of the food sources is not having the enough nectar amount, then that employed bee will become scout, right? Means that it will be abandoned by that bee because enough nectar amount is not there in that food source. Then it will become a scout again. These scouts will simply go around the search area and for discovering the new food sources randomly. And in every iteration, the best find food source need to be memorized. Means it needs to be saved in every iteration by the end of every iteration. And we should keep running these iterations multiple times until our requirements are met. So these requirements can be maximum number of iterations or maximum amount of time, or until you find out a solution that is required. For example, if you are solving a traveling salesman problem and you want to find out a solution which is 100 kilometers, let us say, the distance. So once you met the 100-kilometer distance of this traveling salesman problem, then there also you can stop, right? I will show one simple example over here. Suppose you can assume this one in a multi-dimensional manner where this algorithm can be applicable. For example, this is a Rastrigian function f of x equals to 10d plus sigma equal to 1 to d. So this is how the search space actually looks like in a three-dimensional space where three parameters are there, x, y, z. Sorry, three coordinates are there, x, y, and z. This is how the function actually looks. And we want to optimize this f of x. Means we want to find out the point where this f of x value is maximum, right? So if you see this search space, you can see how many peaks are there. So we want to identify the peak which is having the best value. Here we are checking for the maximum, right? So identifying the peak value which is having the maximum is very difficult in these scenarios. For example, we identified the Rastrigian function, and we need to find out, like a rectangle we consider, we need to find out the best value of this f of x between this, I'm taking here only two-dimensional, x and y dimensions only, 0, 0 to 100, 100. I want to find out the best value of this. I want to maximize the f of x, right? So then what I will do in the beginning, I will take 100 bees. So according to the algorithm, what it says, 50% of bees should be employed bees, and 50% for onlooker, right? So in the beginning, what we will do, this 50% of bees should be employed. So what we will do, we will randomly initialize 50 solutions, means 50 possible solutions, I mean to say. So 50 possible solutions can be like this, whether it can be a 1, 1. So this is one possible solution where maximum value can be found out, and this is the second one. So our ultimate aim is that these possible solutions should be in between this 0, 0 to 100, 100, like 2 to, it might be to 2.5 also. They will be randomly initialized. So like the way there will be around 50 possible solutions. So from these 50 possible solutions, they will be associated with the employed bees. All the 50 possible solutions will be associated with the employed bees. So once they are associated with the employed bees, then what will happen? Fitness evaluation will be done. So fitness evaluation, what happens for every possible solution, fitness value will be calculated. So f of 1, what is the value, and f of 2, what is the value. For every employed B, this fitness will be evaluated, f of 1 to f of 50. So once this 50 evaluations are done, they will be having some values. So we already know our ultimate aim is to maximize this f of x, right? So there might be one solution or two solutions having the maximum value, even more number also. Then what happens? These onlooker B's will be there. These 50 onlooker B's. So they will be waiting in the hive to be recruited for one of the food source, for example, let us say. So how these onlooker bees will select the food source that they want to be hired for. So the formula has been here itself. So based on this probability, these onlookers will actually be hired by one of the food source. So the probability of selecting the first food source is equals to P1, means whatever the fitness value of that first food source divided by sum of the fitness values of all the food sources. And like the way you need to calculate for all the 50 food sources, P1 to P50, right? P1 to P50, we need to calculate the values. So whichever is having the highest value, so the probability of selecting that food source is very high by one of the onlookers, right? So whichever the employed B or food source is having the high fitness value, then they can go to that food source and they keep on extracting. So what actually happens in the extracting time? Means I am telling in terms of that problem only. So this is how a new position will be calculated for every onlooker. I'll tell you with the example only. It will be interesting through example only. If I show mathematical equation, it might be confusing. So these 50 onlooker bees, they will select according to probability of probability factors. So the probability of choosing choosing the one which is having the highest fitness value, right? So might be this f of 1 is having the highest value, let us say. So then what happens? Might be 5 onlookers are interested in exploring this f of 1 even further, and only some 2 onlooker B's are for f2. Since f of 50 is having less value, let us say, then no onlooker B will be interested in exploiting this f of 50 further because it is already having less value. So why this motivation is there actually is that the chance of finding an optimal solution is very high whenever if you are already getting a good fitness value, then we will try to explore in the neighborhood of that only, because if you already got a good solution, then the chance of finding a optimal solution is very high, nearer to that good solution. So that is why whichever the solution having less value, they will not get the chance to exploitation much. This is the one interesting part here in this artificial bee colony algorithm. These onlooker bees will try to maintain that probability. So the probability of choosing a food source which is having high value is very high. So five onlookers will be into this f of 1. They will be further exploiting this f of 1 only, and might be 2 onlookers for f of 2, let us say. And this 15th one, 0 onlookers are interested in f of 50 because it is having very less fitness value. So then what these onlookers will actually do, they will try to search within the neighborhood of it. For example, f of 1 is, excuse me. So this first first solution is something like this, right? 1 1 code, xy coordinates are 1 1, right, for the first solution. Then the fitness of this one might be somewhere 50. Then what this onlooker will try to do is that it will try to modify the coordinates of this one by following a procedure called let me show this one. Yeah, based on this mathematical equation, they will try to modify the coordinates of it. So what can happen here in this case, from 1 1 to either 1.1, or it will try to randomly modify these coordinates 1.1 to 1.2 or even 0.9, means these are xy coordinates, right? Then it will fitness value of this value will be evaluated. So if fitness value of this newly founded coordinate is very high, for example, earlier f of 1 1 is equals to 50, and after finding out the new food source 1.1 0.9 is very high, let us say 55 is the fitness value, then what it will do, it will simply whatever the previous one is there 1 1, that will be forgotten by the employed B, and now it will associate the new solution which is having a high fitness value. So 1.1 0.9 is having the high fitness value than the previous one, so it will be updated. Sorry. Same way, these 5 onlookers are recruited, right, for this one. So every onlooker will try to modify the same coordinates only, because this 1 1 is having the highest fitness value already. So changing the values a little bit might find out a better fitness value. So somebody got 50 to 55, and another onlooker also tried for this one 1.109. It might have changed it to something like 1.2 or 1 itself. Then if the fitness value comes like 100, so this 100 is having the highest fitness value. So what happens, it will forget all the other things earlier, and it will put only f of 1.21 100 only associated with the first employed B. So like the way every employed B will be fixed to one of the solution, and these onlookers will try to modify the coordinates or these possible solutions. They will try to modify a little bit. If they are able to find out a good fitness value within the neighborhood, then they will be keep on replacing towards the better solution. But in some cases, what happens, suppose there is a 5 5 is there. Let us assume there is a possible solution 5 5, and 50 onlookers try to improve it. For example, they try to modify it to some 5.1 or 5.2. Let us say 50 onlookers try to improve it. So you can think of 50 combinations of these xy coordinates. If even after 50 attempts also it is not improving, then what happens? This 5 5 is simply replaced by a random coordinates. So it will simply generate the coordinates randomly for this one, because we are not able to improve this solution for 50 times continuously. Then what happens? It will simply abandon this 5 5 and to simply put somewhere like some random number 99 comma or 2, let us say. So like the way, if any of the solution is not able to improve continuously for some 50 times or 50 onlookers, then what happens? It will be simply abandoned. Means that it has already reached the local optimal, in the sense this is the best in terms of its neighborhood. So there is no further improvement possible from this 5 5 within the neighborhood, and we'll simply replace it with a randomly generated coordinates. So now itself you can assume how this algorithm actually works. For example, if you do an exhaustive search between let us say between 0 0 to 100, so we don't know, this is a continuous value, whether the optimal solution can be found in 0.1 0.1 or 99.99.9 70 70. We don't even know exactly. But if you try to do the exhaustive search process, it may take some I don't know, it might be even more 1 crore actually for counting the continuous optimization values, I think it will be infinity, because we have no idea to how much extent we need to go. Sometimes what happens, 0.11 or 0.22 also optimal solution can be there, depending on the type of fitness function we are looking for. So in these kinds of cases, the exhaustive search is not possible. In a continuous optimization problem like this, we need to come to one of the bio-inspired or swarm intelligence-based algorithm. Might be genetic algorithm also you can consider. So if you do the exhaustive search process, you need to spend infinity amount of time to find out the optimal solution. But by using this either artificial weak colony algorithm or one of the technique, you may not be able to find out an optimal solution, but some very good solution within short time you will find out. That is the main advantage of this algorithm. In fact, I use the same artificial weak colony algorithm for solving one railway routing problem in France. So I did my postdoc from France, where I worked on one of the railway routing problem that I'm able to solve through an artificial weak colony algorithm within a short time. So like the way, first of all, you need to identify the problem, and then you need to design this artificial weak colony algorithm in such a way that it will adapt according to that problem. Now I will try to show one of the combinatorial optimization problem I worked on with artificial weak colony algorithm. So do you have any doubt so far on this algorithm or any of the things discussed so far? Yes, someone? Okay, if there are no doubts, then I will continue with my presentation. So this is for one of the continuous optimization problem, how this artificial weak colony algorithm can be used. So the same thing, whatever I told, this mathematical equation try to find out a new position in the neighborhood. If in this new position, if some good solution we are able to find out, then that will be replaced. Earlier solutions will be replaced with this new solution. So like the way we should keep on iterating it until we met a termination criteria, whether it is maximum number of iterations or execution time, or certain amount of certain solution value, certain fitness value we are able to find out. When it comes to the Scout B simply takes one of the random number. Rather than using the neighborhood values or anything, Scout B will simply take one of the random numbers between the limits, between the min and max. So here R is a random number. So as a diagram, you can see like this, this red colored are employed bees, means these food sources are associated with employed bees. So this is where employed bees are extracting their nectar. These are the red colored or employed bees food sources. And once an onlooker is recruited, it will try to find out the neighborhood, how the neighborhood is actually associated with this food source. So one of the onlooker bee can try the in this neighborhood. Another onlooker bee, whichever is recruited for this food source, it will try in the right hand side direction, one in the bottom. Like the way, if any better food source is found, so better food source in terms of the fitness value only, then it will shift to this one. The employed bee will shift to this value because it is having high fitness value. Similar way here also. So this Scout B is a blue colored one. It will simply randomly thrown in one of the search space. So the ultimate idea of this algorithm is that initially we need to capture the search space. Means we need to initialize the solutions randomly all over the search space. In this diagram, we can relate it easily. Initially, we will scatter all the bees around the search space, and it will try to find out the fitness value wherever they are placed. So once that information is there, fitness values information is there, then whichever the coordinates or whichever the solutions having highest fitness value, then more number of exploitation can be done in terms of onlooker bees. So whichever is having the high fitness value, that is having the chance of being selected by more onlooker bees. If more onlooker bees selected the that one, then it will try to search in that neighborhood of it. So we can reach the peak at some moment of time. But what happens, there are some smaller peaks over here. Suppose it reaches one of the smaller peak, and continuously for 50 times or 100 times onlooker is trying to improve it, because it is already a local peak and it in the neighborhood there is no better solution found. Then what happens, we will simply abandon that one, and then we will start a scout B procedure. Scout B will simply take a random coordinate among this again, and if the fitness value of that one is very high, then more onlookers can exploit on that. So this procedure keeps on being done in an iterative manner until the termination criteria met. So and the idea of this artificial B-column algorithm is that it will not guarantee any optimal solution, but it will give a very good solution within short amount of time, which is required in many real world problems. We can't simply search for an optimal solution continuously for 1 month or 1 year. You might be wondering how much time it will take for optimizing this procedure, optimizing this problem. Let us take this Rastegan function. According to an exhaustive procedure, it might take years also to find out an optimal solution. If you follow any exhaustive procedure, or suppose you might be knowing, right? If you want to search each and every coordinate like 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and so on. But then here continuous optimization, interesting thing is that the optimal value can lie in between the values also, 0.55, 0.66. We don't know where exactly it can be find out. So it might take years also to find out an optimal solution for a problem like this. But this solution is required for some real world problem. Like I said earlier, one of the railway routing problem that I have solved, it is taking 2 days time for a traditional algorithm to solve. But what is the use if you are able to get a solution within 2 days? The trains need to be timetabled within 15 minutes itself, or due to the disruptions in the railway procedures, whether some train got delayed or some train came before time, then rescheduling the trains is very difficult. So if you take any traditional algorithm, if it is taking 2-3 days time, then what happens? These trains can't wait for 2-3 days. They need to be scheduled within 15 minutes. So then in those cases, we can use the algorithms like this. Within 15 minutes, we will try to get a very good solution within that short amount of time, 15 minutes. And whatever the solution we are able to find out, we will schedule the trains accordingly. So like the way the real world many real world problems can be solved by using these bio-inspired or swarm intelligence algorithms within short amount of time. Now we will see one of the combinatorial optimization problem and solving it by using ABC. So far, if you have any doubts, you can raise. Okay, fine then. So basically, what is a combinatorial optimization problem? So if you the most interesting thing that we need to do whenever we are solving a problem is that we need to do the research on that problem first. What kind of problem it is, whether it is a continuous optimization problem or a discrete problem or a combinatorial optimization problem or a multi-dimensional problem or multi-objective problem. We need to identify that. So in all these problems, what is actually a combinatorial optimization problem, we will see now. So these combinatorial optimization problems occurs in many areas, spanning over computer science or EC, mechanical, you name it. In many areas, these combinatorial optimization problems will occur, and they are discrete and finite in nature. And most of these problems are NP-hard, and solving them within a small amount of time is very difficult. And if you are able to design any algorithm to solve it, then it will be very good. And for most of these problems, this traditional methods will not work, whether it is exact methods or any exhaustive search. The traditional methods will not work in solving these NP-hard problems. Then we need to come to the rescue by one of these algorithms, whether it can be artificial weak colony or one of the bio-inspired or swarm intelligence only, we need to approach. So the definition of combinatorial optimization problem goes like this. So this is this problem can be represented by using a triplet like S, omega, and F. So S means the set of feasible solutions, and omega means the set of constants, and the F is the objective function. So based on the type of problem, they can be even further categorized into three characteristics. If a problem is requiring permutation, so for example, solving the problem requires arranging a given set of objects into particular order. For example, traveling salesman problem, which means this solution for this traveling salesman problem requires arranging the objects, right? So that is categorized as a permutation problem. And subset selection problem means knapsack, means you need to identify a subset of objects. So that is a subset selection problem. And this classification or bin packing or clustering, so those are called as grouping problems, because solving those problems requires partitioning the given set of objects into various groups. Suppose if you are doing the clustering of some data, so it can be divided into 4 clusters, let us say. So we need to partition the whole set of objects into clusters. So that is a grouping problem. And the bin packing problem, so there will be a set of items, and the set of items need to be inserted into the bins. So this bin is called as a group. Every bin is called as a group, means we need to partition these whole objects into various groups. These kinds of problems are called as grouping problem. Even classification problems also comes under grouping. Suppose you are already having some training data which is divided into 4 clusters, let us say 4 classifications, and there is a new new data point or something is there. Then you need to classify it into one of these clusters. So that is also called as comes under a grouping problem. Classification also comes under a grouping problem. So first of all, we need to identify which characteristic the problem is actually having. So it can be one of these 3 if it is a combinatorial optimization problem. Now we will see one of the combinatorial optimization problem and try to solve it by using ABC. So once a nature has been identified, whether a problem is permutation or subset selection or grouping, sometimes what happens to set our headache, it might come as a combination of multiple aspects like this. It can be a combination of permutation or subset selection, or subset selection or grouping, or it can be permutation or grouping. Then it will be even difficult to solve those kinds of problems, because solving one aspect, solving simply traveling salesman problem itself difficult. But then what happens if multiple aspects are there in the problem? Then we need to design our algorithm in such a way. And this representation of solution plays an important role, because taking the decision on this representation will play a very important role, because whether this representation provides easy implementation or not, sometimes what can happen, some redundancy can be there on the type of representation. So we need to carefully select which representation is required for a particular solution. And gaining the domain knowledge within the problem is also required to propose any heuristics like this, either ABC or ACO or genetic algorithm. Right. So these are some of the problems that me and my students, my PhD scholars have worked on, and multiple papers are there on those problems. So all of them are combinatorial optimization problems, categorized according to their aspects, their characteristics. So these top 2 problems are having all the 3 characteristics: permutation, subset selection, and grouping. These problems have all the 3 aspects. But whereas the second set is having only permutation and grouping, some are having permutation and subset selection, and one is having only permutation, and the 3 are having only subset selection. So we will take this generalized covering TSP for today's experiment. And we will see what exactly the definition of this problem and how we solved it by using artificial weak colony algorithm, we will see. So basically what this problem is that, this is proposed by Shelley et al. So given a graph having a set of vertices and edges. So in this set of vertices, the three categories are there. One is the depot, another one is set of facilities, and another one is a set of customers. And for this problem, there is a given demand, and there will be a coverage radius associated with every facility, and one demand is associated with each of the customers. So this is an NP-hard problem, and solving this problem requires a minimum length tour over a subset of facilities. So I will show you a graph or figure so that it will be easy for you to understand. Suppose this is the given instance where 51 cities are there, and these 51 cities are categorized into three. So this triangle, black triangle, is a depot. Means whatever the tour you want to start, you have to start from the depot only, and you have to end at the depot only. And these red colored square are representing the facilities, and every facility is having a coverage radius. It means that if you approach that facility, it means that you are able to serve those customers. These customers are in the blue colored dots. So this is the given instance, 51 cities containing one depot, 14 facilities, and 36 customers. And our required demand is to meet 24 customers at least. So as I told you, if you are able to approach one of the facility, means that whatever the customers coming in the coverage radius, their their demand is met. So the demand is 24, means that we need to cover 24 customers by using any algorithm. We need to find out for requiring this demand 24, which facility needs to be visited. Starting from the depot, which facilities needs to be visited, and in which order also matters. So here the objective is to minimize the distance starting from the depot and end at the depot. At the same time, we need to meet this demand of 24. So as you can see here, this problem requires identifying the subset of facilities. There are multiple facilities over here, but we need to identify a subset of facilities first, right? And after identifying the facilities, we need to order them, in which order we need to visit these facilities. So it is a very interesting problem, having many applications in either telecommunication networks or wireless sensor networks, and humanitarian relief transportation. Let us assume that something has been planned, or some floods came, then we need to distribute the foods across the people. Then we need to identify immediately a route in such a way that most number of what you call, I'm not getting to that one. Flood effects might be there. Many flood effects might be there. We need to maximize the benefit for most number of flood effects. For example, here it is given as 24. So we should be able to reach 24 flood effects in such a way that we need to select the facilities and in which order we need to visit. Ultimately, the distance also needs to be minimized. Right? So for this problem, we will see how the artificial bee colony algorithm can be used. So as I told you already, there are two aspects over here. One is subset selection, identifying the subset of facilities to meet the given demand, and permutation means we need to order those facilities, in which order we need to visit these facilities. So multiple applications are there in telecommunication networks, humanitarian relief transportation, and it can occur in many location routing problems also. Let me go back once. If anyone is having doubt in understanding this problem, you can raise the doubt now, because if you understand this problem clearly, then only you can understand further procedure also. Someone? Okay, if no one is having the doubt, then we'll proceed. So as I told, these two aspects will be there. Then how we will use this artificial bee colony algorithm for this. So the basic artificial bee colony algorithm framework only here also we are taking. So these are the inputs expected for the artificial bee colony algorithm. So in set of parameters need to be given for ABC. Set of parameters in the sense how many number of employed bees and how many number of onlooker bees, how many scout bees. All this information needs to be given in prior to this ABC algorithm, and then the output will give the best solution found so far. So in the beginning, the solutions will be initialized randomly. As you already know, all the possible solutions will be initialized, and then we will move to this main phase, employed bee phase. So during the employed bee phase, every solution will be associated with one of the employed bee. Then based on the association, the employed bees will calculate the fitness values. So here the fitness value is the distance, right? The distance needs to be minimized. So the distance is the fitness value, and the fitness value needs to be minimized. Then what happens is the onlooker bee phase. What happens in this onlooker bee phase is that the onlookers will choose the employed bees which are having solutions with the minimum fitness value, because ultimately the aim is to minimize the fitness value. So these onlookers are interested in finding out the minimum values. So once these onlookers are recruited, they will try to find out the neighborhood in that solutions, right? So within the neighborhood, if some better solution came, then it will be updated. And if any solution has not been improved over certain number of iterations, they will be moved to scout bee phase, where the solution is simply replaced by a completely new solution, completely new feasible solution. I mean, whenever I am saying a solution, it must be a feasible solution in the beginning itself. And we should iterate this procedure until the termination criteria is met. So a detailed procedure can be seen over here, what exactly happens in every phase. So in the initialization phase, all the solutions will be initialized, and in the employed bee phase, food sources or solutions will be associated with these bees. And during the onlooker bee phase, it will try to find a new solution for everyone. And if it is able to find a better one, then it will be replaced. If some S dash is better than SP, then it will be simply replaced. And during the scout bee phase, what happens? If any solution has not been improved over this parameter, limit scout, this is also a parameter that may need to be tuned according to our problem. So if we are not able to improve any solution for this many number of times, then it will be replaced by a completely new solution, means a random solution. So that is under scout bee phase. So we will see how this initialization phase happens in the beginning, and then we will see how the neighboring solutions, these new solutions, are generated in onlooker bee phase, right? So as I told you, the solution encoding, the representation is very much important in solving problems like this. So here in this problem, the solution we encoded directly as a linear permutation of subset of visited facilities, where the depot is always occupying the first position. So you might be knowing all these things. If you are already knowing traveling salesman problem, then you can easily understand this. Suppose there are 51 cities, let us say 1 to 51. So out of that, facilities are only some 10 facilities are there. So some subset of facilities we need to select from those 10 facilities. So they will be encoded directly as a linear permutation of those visited facilities. And the fitness value is the total distance of the tour, and it has to be minimized. Our ultimate aim is that we need to identify this total distance, and that total distance needs to be minimized, and it has to follow the constraint of requiring the given demand. For example, earlier the given demand is 24. Same way, the user can give the demand in their manner. So how the initial solutions are generated? So initially what we are doing, we will select an unvisited facility by using these three heuristics. Okay, how the initial solutions are generated, I am saying here over here. We will select an unvisited facility according to these three heuristics. Out of that, first heuristic is that it has to be least insertion cost. Means we will identify a facility which is nearer to the present position, right? Means which is nearer to the depot in the beginning. then means whichever the facility is nearer, then that will be only having the least insertion cost, right? So that will be selected according to this heuristic, whichever the facility having the least insertion cost. And sometimes a facility is having coverage, more coverage than the other facilities. For example, I don't know whether I can skip back, it may confuse. So some facility coverage is very high, then the chance of selecting is also very high, right? For example, a facility is covering only 10 customers and another facility is covering 20 customers. So if you select that facility, then you can cover more customers. So I will take the facility which is having 20 customers only. So this is another heuristic. And another heuristic is completely take a random facility, means somewhere some random facility you take and you insert it into the initial solution. So we should keep on inserting these facilities until the given demand is satisfied. For suppose given demand is 24, so we need to keep on adding these facilities until we meet the demand 24. But then the interesting part comes, the order of the facilities also matters. So then we will try to solve the permutation problem in that. So how these neighboring solutions are actually generated? Once this, as I told you, these initial solutions are generated according to this procedure by using these three heuristics. Okay. And once these initial solutions are generated, they are associated with the employed bees. So during the employed bees, they will calculate the fitness value. That is, anyway, it is over. But during the onlooker bee phase, it will try to generate the neighboring solution, right? So there are two methods proposed for generating any neighboring solution. So neighboring solution in the sense, whatever the present solution is there, by doing some changes to it, we may able to get a better solution. So that is the motivation here. So motivating from that, we proposed two methods. One is a subset DRO. Means DRO means here destroy and repair operator, and another one is permit DRO. So this subset DRO will take care of the subset selection. So it will randomly remove this many number of facilities from the tour, and again according to this score, it will add the facilities back. For suppose some diagram is already there, I will show that one. So during this destroy and repair operator, whatever the tour is already there, that will be destroyed. Means that some of the facilities will be removed from the tour, and again new facilities will be added according to this score. And based on this score, new facilities will be added until the given demand is satisfied. And during this permit DRO, what happens here? We will take only we will take care of permutation only. Means the facilities are going to be same, but their order is going to be changed. Means we will remove the visited facilities only, and we will try to we will try to put them in different positions. The same facilities only will be there, but their positions will be changed. I will show a simple example of this one. For example, there is an initial solution like this. This is example. The top one is example for subset DRO. How the neighboring solution actually generated. So 1, 2, 3, 4, 5, 6 is an initial solution, and then after removing, means after destroying the facility, some of the facilities, it becomes 1, 3, 6, and from here 1, 3, 6 based on the score that has been identified. So the score will be calculated for every facility, and whichever the facility is having the highest score. So as you can see, the score is proposing that whichever the facility is having the highest coverage and it is having least insertion cost. So according to this formula, the scores will be calculated for every facility, and whichever the facility is having the highest score, they will be inserted in the tour. So here 136 is there, and the score has been calculated. Now it became 17836. So this is the new tour, which is a better solution than the previous one. Then we will simply replace. Otherwise, we will continue with the same 1, 2, 3, 4, 5, 6 only. But this time, another random set might be deleted from the facilities, and again scores will be calculated. Based on the scores, some of the facilities will be added. As you can see over here, in the beginning 1, 2, 6 are there, but after doing the procedure, then 17836 is there. Means that the facilities are changing. At the same time, their positions are also changing here. Earlier, the 3 is in third position and the 6 is in 6th position, but now 3 is in 4th position and the 6 is in 5th position, and the set of facilities also changed to earlier. And here in this permutation DRO, what we will do, we will take the input solution same here, but we will simply remove them randomly from their places. Like 1, 3, 6 we make, and 2, 4, 5 are there, and this 2, 4, 5 will be calculated in such a way that we will take this 2, and where it requires less insertion cost, so there we will insert that one. We will take this 2 and we will try to insert between 1 and 3 and 3 and 6 also. Then wherever it is less, we will insert there, and we will take 4 again, and at the time of adding 4, whatever the positions are there, all will be calculated one by one, and that will be inserted. And this 5 also will be taken, and all the positions will be evaluated. Wherever it is getting the less cost, it will be placed there. So as you can observe here, in this subset DRO only, in this subset DRO, set of facilities are changing, their order is also changing, means in which order we are visiting them. Whereas in the permit DRO, only permutation is changing, but the set of facilities are going to be same. So like the way we took care of both of the aspects. One aspect is subset selection, another aspect is permutation. Like the way while taking any problem, we need to decide how many aspects are there and how to address each of that aspect. Then only we'll be able to solve the problem in a very efficient manner. So here one interesting thing is that this degree of perturbation is there. For example, here I told the DP into number of visited facility. So this DP is another parameter that we have introduced. It says that this DP is going to be changed according to the number of iteration, because in the beginning, in the initialization phase, most of the solutions will be random only. So then we might require to change so much in the solution, means we need to perturb a lot in the beginning. So the DP value will be very high in the beginning iterations. The removal will be very high. Means as you are approaching towards a better solution, then we might require little changes only in the solution, right? Means little changes only in the tour are required. So this DP value is going to be decreased over the number of iterations. So how we did that? According to a formula, we did that one. So the aim of this formula is that the DP value will be very high in the beginning iterations, because in the beginning solutions requires a lot of change. But as the algorithm progresses, we might be already near towards the optimal solution. So then little changes are required in the solution. So the DP value is going to be decreased over the course of this algorithm. So two variants are proposed. One is ABC FDP, it means fixed degree of perturbation, where degree of perturbation is fixed at 0.5, and ABC with a variable degree of perturbation. This here in this ABC VDP, DP will be calculated for every iteration according to this formula, and according to this formula only the perturbation will happen. So perturbation means the rate of change in the solution. So the rate of change in the solution should be high in the beginning, and at the end of the algorithm, the rate of change should be less. So I will present some of the another interesting things also regarding this algorithm. So whatever the problem that we have solved, then there is a scientific procedure to prove that your algorithm performed better, right? So we have taken all these all the instances from Shelley et al. Paper, and on the same instances we executed our algorithm too. But these are the parameters values followed in this artificial beacon algorithm. There are around 6 parameters. In my opinion, any optimization procedure you want to do, whether it is related to neural networks or some other area, machine learning or big data whatsoever, definitely there might be some parameter tuning is required. So based on the set of parameters only, our algorithms are going to perform better. So for this parameter tuning, I have used an Taguchi's method, which is a very interesting one. He is a researcher from telecommunication networks area. He proposed a very interesting method for tuning the parameters. So by using that method, I tuned all these parameters. So I have given a range between 75 to 125 for this number of employed bees, and for the onlooker bees, I have given a range from 125 to 175. Like the way for every parameter, you should give a range. Then this method will identify the which one is the best value and the best set. best set of parameters it's going to identify. Then we can run that algorithm on that particular instances taken. So for comparing our approach and algorithm results with the previous others, they run their algorithms on some machine which is having some 3.10 gigahertz, and we are having a system of 2.27 gigahertz. So what we did, we run the execution times according to the same amount of time, so that there will be no mismatch in the comparison, right? So once after comparing the results, we are able to find out that this artificial B-call algorithm with variable degree of perturbation is able to perform very well in the most number of instances. Yeah, here. So the previous approaches are flow-based formulation and node-based formulation, memetic algorithm, and variable neighborhood search. And we compared our algorithm ABC VDP, and ABC FDP is also ours. We compared, we are able to find out that this ABC VDP is performing better than all the previous approaches, and better than ABC FDP also. And we did this statistical test too, to rule out any possibility of questioning by any researchers. We did the statistical test too. It is a Wilcoxon signed rank test. So here also it proved that our approach is able to perform significantly better than all the previous approaches, whether it is flow-based or node-based, memetic algorithm, or variable neighborhood search. And these are how the convergence behavior is actually working on the problems. As you can see, our ultimate aim is minimizing. So whenever our algorithms are initialized, they are initialized somewhere around here, and over the time, we are able to come nearer to this. So within very short time, we are able to reach to a very, very good solutions. So this red colored one is ABC FDP, and black colored one is ABC VDP. So they more or less performed equally throughout the time, but a little difference is there. But this difference is very significant compared to the previous approaches. And conclusion and future work, this artificial B-call algorithm can be used for solving any kind of problem, but you need to set this framework in a proper manner. And definitely it will perform faster than other approaches based on of your designing with respect to that problem. First of all, you need to identify that problem, and then after identifying the problem only, we can design the internal aspects of it. In my opinion, this, whether it is artificial B-call algorithm or anti-colony, whatever you name it, they will just try to help as a framework, but ultimately it is your job to identify what to put in that framework. So these are just frameworks only. You can use those frameworks and get most of it by proposing more internal things, which heuristics, underlying heuristic needs to be designed. For every problem, they might be different, right? So these are just generic frameworks, can be utilized to solve any kind of problems. And for this particular problem, whatever the algorithm that we have designed, the same algorithm can be utilized for problems which are having permutation and subset selection and characteristics. And you can use this variable degree of perturbation concept wherever you want to search the process in a quick manner towards the optimal solution. So these are some of the references that I have used. And thank you. So before asking the queries, these are some of the problems that I'm working on. And one DST project is going on under my guidance. So you can apply, not you can apply, you can inform it to others of your students. Since it is a faculty development program, I am assuming that you're already settled. But if there is anyone known to you, you can refer them to JRF position in my project that is going to be announced soon. And you can apply for the PhD admission also in our institute. Yeah, thank you. If there are any queries, I'm interested in listening to them. Definitely. Yes. To take motor. Any queries from the audience side?
Hello, sir.
Yes, Srinivas, tell me.
Sir, actually, I'm new to this optimization. Actually, I'm planning to do one research. So my guide is suggested
Okay.
in the optimization. I want to some little knowledge is there. How can I improve on these? I just I'm going on basics onwards.
Okay.
So for any suggestions, sir, for to get a command on these optimization techniques.
Like I told initially, some expert has to be there to guide you. Otherwise, you'll be wasting your time unnecessarily. So, as I told you, first of all, you need to identify which kind of problems you want to solve. And depending on that only, you can take one of these techniques. So, as I told you, once you identified that problem, for every problem, different kinds of exploitation and exploration is required. For example, if you name traveling salesman problem, so it will require
Okay.
only so much of exploitation. Exploration is not that much required because anyway it is a permutation. You can simply swap or exchange the cities. Only exploitation is required. But whereas one of the graph that I have shown in a three-dimensional search space, there sometimes you might require more exploration than exploitation. Then we need to find out the algorithms accordingly, which framework supports well towards that problem. So that you need to refer some papers. I will show. So I can distribute. So only thing is that you need a lot of practice. Let me share the screen once. For example, here itself, this home page of you are able to see my screen, right?
Yes, sir.
Yeah, this home page of this artificial bee colony is there. So they have given this codes for this artificial bee colony algorithm, whether it is a C version or Java code, whichever the language that you are interested in, and this Python code also they have given. So you can take the data set from there are some benchmark instances are there. I think CEC, you might be knowing the conference, Congress on Evolutionary Computation. CEC benchmark functions will be there. So like Rastrigan and Rosenbrock, they proposed some benchmark functions. So for all those benchmark functions you can take, and then you can start applying this artificial vehicle algorithm, or many algorithms are there in my opinion, but every algorithm is having its own potential. And you need to come up with the variants of the algorithm, or you want to use the same algorithm. You can propose your new version of artificial beacon algorithm also by changing some of its procedures. There is no denying about like you need to go use only this technique. Sometimes what happens, you can take the same artificial beacon algorithm and you can vary a bit according to your problem, right? Yeah.
Okay.
And the other queries, and these frameworks or algorithms can be used for tuning the parameters in neural networks also. Might be for every a node or edges, you might have to identify the weight of each edge. So weight is, you can consider weight like a parameter, and tuning that parameter also can be done through these optimization algorithms. You can even use it in deep learning, how many number of nodes you need to take and how many number of levels you should take. So all these things can be given as a problem to these algorithms, and let them identify the exact parameters, means how many nodes are required and in how many levels it is required and how much weight should be taken for each of the nodes and edges. So they can also be solved through these optimization algorithms. But nowadays, in my opinion, most of the people are simply going through the designing some neural network with a random number of nodes and then random number of levels. That may not fetch a very efficient results within short time. So you can tune those parameters of a particular neural network or any framework, whether it is extreme learning machine. So those things, those optimization can be done through these algorithms. You just need to frame the problem in a mathematical manner, and after framing the problem, then after defining the problem, then you can start proposing the underlying heuristics in each of these algorithms. Like I said, this framework is going to be same only, whether it is employed B-phase, onlooker B-phase, or scored B-phase. Framework is going to be same, but the underlying aspects, means how you will initialize the solutions and how the neighborhood needs to be explored. You can give some formulas also related to your problem, and then you keep on run this algorithm in an iterative manner until some termination criteria is there. Yeah.
Sir, is there any criteria for selecting random values? You use where random R. So is there any criteria to select the random value R? Or it will depend on the problem?
Yeah, actually, initially they have proposed it in a random manner, because if you see the Rastrigan function, like I have shown, let me go back to that. Suppose this Rastrigan function is there. You are able to see my screen, right?
Yes, sir.
Yeah, this function is there. So here we don't have any knowledge about this problem. Simply it is a fitness value, and this is the formula of how to calculate the fitness value. So here we are having no idea about how to explore the neighborhood. But if you know the problem domain, like a traveling salesman problem, let us say, or some knapsack problem or some bin packing problem, there you have problems knowledge, right? Suppose in traveling salesman problem, you know that if I take a nearest customer or nearest node, then I can improve the solution. You know that information related to your problem. But whereas in problems like this, Rastrigan function or Rosenbrock function, some functions are there. So there is no knowledge about the problem, and nobody can do anything with that. So they need to simply explore randomly across it. But the only plus point you get by using this form behavior or artificial Beak-Colney algorithm is that at a time 100 solutions will be generated initially, and every solution will be exploited by this onlooker bees one by one. So then what happens, the plus point is that things are going to happen in a parallel manner. Then we can capture this search space in a very easy manner. Like the solutions are thrown across the search space, and you can exploit them one by one, even in a random fashion also. But whereas if you are having the domain knowledge, like for example, if you take TSP knapsack problem, you already know which item needs to be taken. If you directly follow the greedy procedure for a knapsack problem, what will happen? You will get a very bad solution. I'm telling about I'm telling about 0-1 knapsack problem, where you need to take an item or not take an item. It is 0 or 1. So in those cases, if you follow greedy procedure, you will not get the best solution. Then what we can do, we can design a neighboring solution in such a way that some of the items in knapsack you remove in the beginning, and later based on the weightage, means you already know, right, the formula profit by weight. So by using the formula profit by weight, so you add the item which is having more profit with less weight. then the chance of getting good solution is very high. But in these kinds of problems, particularly continuous optimization problems or Rastrigan or Rosenbrock, there is no idea. Nobody is having the domain knowledge because it's simply a formula only. Nobody knows what happens inside this formula. Then we need to search in a random manner only. And even after searching randomly for 50 or 100 times, let us say one parameter you take 50 times or 100 times, if you are not able to find any better solution, then you can simply abandon that and you generate another initial solution, that is a scout B. So scout B simply takes one of the random position in this search space. Then you start exploring or exploiting from that place. And if it is also not improving, as you can see, if it is started somewhere in the downside, then definitely it will reach one of the peak. So if one of the peak is reached, then we may not be able to improve it further. Then we need to abandon it. Means the moment if I am saying abandon means you will remember that solution, whether it is the best solution found so far or not. If it is already a best solution, that will be remembered throughout the algorithm. If it is not best solution, then we can simply replace it with a some random solution in this procedure. Yeah.
Okay, sir. Thank you.
The main idea here is that for continuous optimization problems, it has already been reached a saturated level, I can say, because here no problem related information is there. So anybody can design algorithm and can get a better value. So many algorithms have been proposed like that. It has already reached a saturated level. But now the real research is that you take any real world problem like some combinatorial optimization problem or multi-objective optimization problem, or even if nowadays related to IoTs or machine learning, neural networks, you can define and formulate those problems, and then you can use this optimization techniques, bio-inspired or swarm, whatever. Yeah. Yes. Any other queries?
Hello, sir.
Yes.
Sir, the scope in actually I am planning to apply the work on brain-computer interface, sir. EEG
Okay.
dataset.
Okay.
What is the scope, sir? Research scope for to proceed? I want to apply some optimization in the EEG data.
Okay. So you have already identified the problem and defined the
No,
problem.
sir. This is the starting stage. Yeah, starting stage only. Just I'm planning to finalize the objectives. The
Okay.
coursework is completed, but I want to finalize, sir. But my guide is suggested I'm keep on some working. I am attending all the workshops and I'm preparing this optimization technique and easy data set also I'm seeing.
Okay. So is there any way like after defining the is there any way that you can define the problem statement, like these are the inputs are going to be given and some fitness, well, some objective function is there with respect to that? For example, I will tell you a simple one, like just now only we have taken some Rastrigan function of, let us take a circle equation, f of x is equals to x square plus y square, and for this x and y, for this x and y, I have given the range from 0, 0 to 100, 100. Means the two-dimensional space I have given, and I want you to maximize f of x, that is equals to x square plus y square, right?
Okay.
Are getting it? Are there any inputs and exact definitions are there like that in that problem? First of all, you need to identify that.
Okay, okay.
So once you identified the problem, then you should be able to generate the possible solutions for it. For example, if the moment I told f of x is equals to x square plus y square, I need to maximize. Then I can say, I can take any random value between this 0, 0 and 100, 100, right? So 1, 1 I can take, 2, 2, 3, 3. So like the way many number of solutions I need to initialize. Let us say I have 100 employed bees, so I can generate 100 solutions randomly like that, and I can evaluate this f of x value for that. So for 1, 1, this f of x value is going to be 2 only. But whereas in 2, 2, this f of x value is going to be 2 square plus 2 square, so equals to 8. So this is having the highest fitness value. Means if we are having particular definition and particular objective function and input values, then only can design algorithms like this, whether it is with artificial B call or ant colony. Yeah.
Okay, sir. Okay.
Yeah, means if you are having any queries related how to design a particular algorithm for a particular problem, then you can mail to me also whatever the data that you are able to find out so far. Like you might be already knowing this. For some of the problems, you need to collect the data set also in the beginning itself. For example, if you take an abstract problem or a TSP problem, there is no need of collecting the data set. There might be so many instances already available. So once you identify the data, then only you can formulate the problem and you can come to a certain point. So this is the fitness I want to improve. For example, for the same thing, I will tell an example. I will take a traveling salesman problem. Let us say, so where the fitness value can be related to distance, right? Distance needs to be minimized, or somebody else came up with another objective function that the travel time needs to be reduced. So one guy is saying the distance is its objective function. Another guy is saying that time is the objective function, and some other guy also will come up with the amount of petrol that has been consumed or amount of pollution that has been done during this travel that needs to be reduced. So if there are different kinds of objectives or multiple objectives, then we need to design the algorithm by taking care of all the objectives. Distance also we need to minimize, the time also needs to be minimized, and the amount of pollution that is causing also needs to be minimized. Yeah, the amount of natural resources that it is consuming, whether it is diesel, petrol, or whatsoever, the consumption of these natural resources also needs to be minimized. So we need to take all of these things into account. The moment you come up with one problem, you need to identify all the aspects of it. It's not like you can directly apply the algorithm. First of all, we should do our groundwork on the problem, and we should get the domain knowledge in that. And if you are able to formulate the objectives in the inputs that you are going to get, based on that, the algorithm needs to be designed. Yeah. Any other queries? Someone is trying to speak, I think. So you can write to my mail ID also if you are having any queries or anything. So else, I need to share this presentation and the advertisement related to my JRF also. I will send it to Lavanya ma'am, so she can send it to you all. So if there are anyone interested in doing the JRF, or if you are having time, if no one is having the doubts, I will walk you through the advertisement notification of my JRF position once. Yeah. So this is the research that has been being granted from DST, sir. Investigation and development of heuristics for network design problem using different topologies. So it is of 2 years term and funded by DST, sir. And one position is there, and the qualification is that BTech with valid gate score or ME or MTech. Yeah. So it will be 31,000 per month. I will share this with the DP organizer Lavanya ma'am, we can share it to you all. So you can refer to the candidates that you might be knowing. And PhD admissions are also going to announce in my institute twice a year, one in January session and another one in July session. You can apply to that also. So the last date for this notification is 5th March 2022. That's from my side. Sorry. Yeah.
Thank you, sir, for your valuable talk and for enlightening us.
Thank you, ma'am. Thanks for giving this opportunity, and thanks for inviting me to this FDP. Thank you.
Thank you, sir.
So if there are any queries we can take, or shall we wind up, ma'am?
We'll join back again at 9:30 tomorrow morning. Thank you all.
Okay, ma'am. Thank you all. Hope so we'll meet again.
Thank you.
Thank you, sir.
Thank you so much, sir.
Thank
Thank
you,
you so
sir.
much, Venkatesh, sir.
Thank you, sir.
It's a great thing, sir. With this, we are very happy about this. So with this workshop, I think you have announced some JRF positions also.
Yes,
It's a
ma'am.
very good thing, and on behalf of our side, we feel very happy, sir. And with this information, any people got benefited, then on
Yeah.
behalf of from our FDP side, we feel very happy, sir.
Yeah.
Thank you. Thank you.
Yeah. The
Thank you
credit
so
goes,
much.
yeah. The credit goes for connecting this FDP also, ma'am. It's both like
Uh,
Swami Karya and Swakarya. Yeah.
Yes, sir.
Yes,
Yes, sir. Yes, sir. Yes, sir. Thank you so much, sir. I request all the parties. I hope today all sessions given things. So the first session and second session both are completely take over by the Damodar Reddy sir. Sir also given opportunity you all of you to visit their campus and to work on the their labs and to know more on the devices, the hardware devices also they demonstrated. And now so the Venkatesh sir also given one more opportunity to be one of the JRF in their reputed institutes. So I hope today's sessions, all sessions will help to you and you gain some knowledge, and expecting same kind of participation by the next 3 more days. So thank you. That's all about the today's sessions, and we are winding up. And tomorrow, the next session will be start at 9:30. Be all of you on the time. Thank you. So anything you wanted to communicate with us, so better you can communicate in the FDP group. So today all feedback links and attendance sheets also we provided. If anyone missed, please fill immediately. So thereby it help us to maintain the attendance. So the maintenance at the end, that there will be a test and you need to score well on that. And today by once we got, then we'll share the link also. Thank you so much.